So we're in our P2 books on page 3. Now I'm going to tell you that I really don't want you taking notes on this, okay, because this part is review. I will tell you what is important in this section. This whole section is on polynomials. Okay, you might have. So this whole section is on polynomials. We're going to add them, subtract them, multiply, and eventually divide. Okay, so let's just, I'm going to do a couple of, like an addition and subtraction real quick. So, all right, this is a polynomial. What's the rule about adding polynomials? You have to what? Add like terms. Do I have any other x cubes? Okay. I have 2x squares and I'm adding 1x squared, so I have 3x squares. I have negative 3x plus 4x's, so I have 1x. And then I have 4 minus 7 or negative 3. So that's a polynomial addition. We've been doing that for quite some time. So what about subtraction? Now, what do you think is the biggest mistake that happens with subtraction? Watching the signs. So if I don't do something to this and I'm not real particular in looking at my work, I'm going to do 3x cubed minus 2x cubed, I'm going to get 1x cubed, and that's going to be right. And then I'm going to do 2x squared, I don't have a 2x squared, I don't have a, and then I'm going to do 4x minus 1x, and I'm going to do 3x. And that's where I get points taken off. I got my points back today or yesterday. A couple of people that passed by 1 point, a couple of people that failed by 1 point. You can't make mistakes on this little stuff. You can't do it, okay? So, what I would advise doing when you're subtracting is distribute that negative and change every sign. And then it's an addition. I mean, most of us, okay, let's think about this. Most of us like to add, right? You're either right-handed or left-handed. You have a thing that you prefer, that you're good at. Most of us are better at adding than subtracting, especially in our heads. And so I think about the servers at Sonic. Any of y'all have worked at Sonic? Did you have worked at Sonic? No? Some of my former students. Okay. Well, at Arby's, you've got the cash register. Not that you need it. But at Sonic, if they bring it out and it's $13.52 and you give them $15, they don't subtract that in their head. They do $13.52, penny, penny, penny goes to 55, nickel goes to 60, and then 4 dimes goes to 14, and then $1 makes it 15. What did they do? They added. I mean, they add. Nobody can, and people say a lot of times that this Singapore math or this Cambridge math, it's crazy. Well, they might think we're crazy trying to go 15.00, borrow 1, put it over there. We can't do that in our head. So we're much better at addition, my point being. So if you can make it an addition problem, you're less likely to make mistakes. So 4x plus 1x is 5x, negative 3 plus negative 7 is negative 10. So we've added and we've subtracted. Okay? Now let's talk about the multiplication. Okay, so what I taught in IGSI 1 is I taught the cover-up method. I'm sure y'all don't need to do that now. But cover up this other term, and distribute. So that becomes x to the third. That becomes 4x squared minus 8x. Now, cover up. The x, which I'll just do it like that, plus 3x squared plus 12x minus 24. So, I have no other x cubes. 4x squared plus 3x squared is 7x squared. Negative 8x plus 12x is 4x. Forgot to cross that one out, minus 24. Now, guys, can we take out our calculators and check to see if I have done this correctly? Okay, take your calculators out, because as much as I can help you practice, we're going to practice. I don't care what you have stored for x as long as it's not 0, 1, or 2. I like 5, but that's me. So you're going to type in this, then you're going to type in this. Get the same numbers. So you know all we've done is rearranged it. So we should be able to get the same numbers. Okay, so what's that leading us up to? Look at page 8. Example 1.3.2. Now you can write this one down. This is the lesson today. That is 3 lines. That does mean equivalent to. It's not equal because this isn't anything to be equal. Like x is equal to 2, that's definitive. But if it's equivalent to, they put the third line right here. I know that's splitting hairs, but. Now let me show you what we're going to do. I'll give you a second to finish writing down the problem. So the first thing that we're going to do is we're going to distribute this, okay, which is just why I had to go over the multiplication real quick with you. All right, so I'm going to cover up the negative 2 in my mind. X times ax squared is ax cubed plus bx squared plus cx. Now I'm multiplying the negative 2. Now you may be thinking, I don't know how to do this because I have one equation or I have 2 equations, but I have 4 unknowns. So how in the world would I do this? Well, this little thing right here is going to help us. So I have an ax cubed. Do I have any other cubes to combine with my ax cubed? Okay. Okay. let me change that to an equals because it is equal to that. Okay, so I can divide by the x cubes, right? So what is a equal to? 4. Because I know that my a cubed, it told me that it's equivalent to something over here. Okay, so I'm done with the cube. What squares do I have? Bx squared minus 2ax squared. Now, and that's going to equal what? What's my x squared on the other side?
2x.
Okay, I'm going to teach you the long way to help you understand, and then we'll understand a shortcut. What can be factored out on the left side? So that leaves me b minus 2a equals 2x squared. I factor it out so that I can divide by it and get rid of it. But the shortcut version is that I can just drop all the x squares. Do you see why? All right, so b minus, now wait a minute, 2a. How can I solve that one equation with two unknowns? Plug in a. A is no longer unknown. So that's 2 times 4. So that would be b minus a equals 2. So b equals 10. So now I have 2 of them. What are we thinking? Questions? All right, so now I've done my x squares, and I'm going to do my x's. So write down your x terms. What are they? Cx. All right, and that is to equal. Didn't have anything, so I put 0. There is nothing over here for my x term. So I can drop the x's, so c minus 2b equals 0, c minus 2 times 20, so c equals 40. Now, one thing that you need to understand. Yes?
I thought B was 10, so it would be minus 20.
Oh, yeah, thank you. And I would have caught that when I checked it. I was just doing too many steps at one time. So C is 20, thank you. Now, looking at, so I'm done with this and I'm done with this. So what am I left with? R and negative 2c. Now, I do have my value of c, but I have to use that to find my value of r. Do these have any x's? So if you don't have an x, you're considered a what? Constant. So I have to take, even though I've already found my c, I still have to take, because I haven't used all that yet, 2c plus r is equal to, what is my constant over here? 3. So negative 2 times 20 plus r equals 3. So r is equal to 43. Now, what do you think about that? You just want to try it on your own? Let's check this one first, and we can check this by putting in the left side. So everybody type in the left side. Press enter. When you get the left side. And then after you get that number, type this in as it's seen, except put your 4, 10, 20, close, plus 43. At least that way you know that you've gotten the right answers. Okay, so look on page 8. I want y'all to do 3A at the bottom. Page 8, 3A.
into questions or problems?
All right, let's work this one out quickly. All right, we have x cubed minus x squared minus x plus 12 is equivalent to x plus 2 times ax squared plus bx plus c plus r. All right, so I'm going to FOIL that out. That's ax cubed plus bx squared plus cx plus 2ax squared plus 2bx plus 2c plus r. Are we okay on that line? If anybody's not, raise your hand. Okay, so my ax cubed is equal to 1x cubed. So when I drop my x cubes, I don't have an undefined here. I have an a equals 1. Okay. Bx squared, and I always like to cross these out. Bx squared plus 2ax squared is equal to negative x squared. So when I drop all the x squares, so b equals negative 3. Is that correct? Is that what y'all got? All right, then cx plus 2bx equals negative 1x. C plus 2 times negative 3 equals negative 1. C equals 5. And then I have 2c plus r equals 12. 2 times 5 plus r equals 12. R equals 2. And y'all should have been able to check these and see if this came out correctly. Okay. All right, before I give you your classwork, let's look at 1A. Now, part of what I want to do in this class is to help you be resourceful in your thinking. So when you get problems like we had earlier in your group work, oh, by the way, I need to tell y'all who won those. So when you have problems like that, you are resourceful enough to figure it out. So we can actually factor this. This would not be a problem for us to factor, correct? So I know my factors of 12 are 1 and 12, 2 and 6, 3 and 4. I have to subtract to get negative 1, so it'll be 3 minus 4. So that's going to be x plus 3, x. Oh, that's supposed to be a plus right there. Sorry about that. I knew something was not coming out right. So it's supposed to be x plus 4, x minus 3. So real easily, I know what's missing right here is the x minus 3. Now everybody take your calculators out and let's do polysolve. And let's see how we could use polysolve to help us with this. So give me your two x's when you get them. Okay, does everybody get those two x's? So looking at what they gave us this one. But I did my polysolve and got this. But what happened here? When they took this and put it here, what did they do? So x plus something equaled negative 4, right? X plus something equaled negative 4. So I'm going to reverse it back and make x plus 4 equal 0. So the shortcut of it is what? Whatever this sign is in the polysolve, when you put it in the parentheses, you change the sign so that when you set it equal to 0, it comes out. Okay, so that's why the positive 3 then becomes what? Negative 3. So I want you to right now to do C and E. And I don't care, you can do them the long way or you can use your polysolve. Yes, 1, C, and E. It's just that left column. All right, on C, what were your two x's? X equals what and x equals what if you did polysolve?
2.
And,
-11.
all right, so they had already given us the x minus 2, so then I could put what here? Okay, we're going to talk about that format in just a minute. I'm going to come back to that. On E, what are the two x's?
-5 halves.
-5 halves and?
3.
So they gave us 2x plus 5. So this one is x minus 3. So what can you conclude looking at that about fractions? Because they didn't give us x plus 5 halves here.
Or they took the 2 away.
Okay, they multiplied by the denominator. So if they had asked you on this one, everybody look at me now. If they had asked you to do x minus 2 and 3x plus something, what would you have put there? 11, not 11/3. So you multiply by your denominator. So those are equivalent. All right, any questions on these? I just wanted you to use your polysolve for another backwards kind of way, because you know they don't do very many things straightforward in Cambridge in this situation. Okay, so your homework is 3, B, and C, and 4A on page 8. So you have 3 problems to work.